So hi everyone, welcome to PyNet Labs. So my name is Chirag and I'll be your trainer for the upcoming batch of NRC training. So this session is going to be a demo session for that, and we'll be discussing things related to NRC, what all we will be exploring and learning about in the NRC training. We'll be discussing about all such things. And then we'll also pick one topic to discuss so that you guys can get the idea how the training sessions are going to be. So let's get started. The very first thing we will be discussing about is the content of NRC. So we should first know how exactly NRC works, what all things are there in NRC before we get started with the topics, right? So let's begin the discussion. The very first thing is that after this training, you will be prepared with the official syllabus of Cisco's NRC exam, under which we get to see four major categories. The first one is going to be your layer 3 technologies. So under layer 3, we all are well aware what all topics are there. So we'll be talking about a lot of things like how to troubleshoot routing protocols. Then we'll be talking about routing protocols like EIGRP, OSPF, BGP. Now, when I talk about these routing protocols, I expect some level of understanding from you guys also, because this is going to be the NRC training. So I expect the ENCOR level of understanding from you all. When I talk about EIGRP, so under EIGRP, we'll be talking about various things like how the address family configurations work, how the stub EIGRP configuration works, how the authentications are done, what is load balancing, how it can be achieved through EIGRP, how the metric can be manipulated. Similarly, under OSPF, what are the various types of LSAs? What are the various types of areas? Like you must have heard about stub areas, NSSA area, totally stub, all those things. Then what is virtual link configuration? How the path can be manipulated? What is the various types of networks which we can configure using OSPF? Similarly, under BGP also, we get to see address families, next hop configuration, multi-hop. So we can say under all the routing protocols, there will be multiple features which we will be discussing about. All these features comes to the level which is the advanced level. So basically, we'll not be talking about all the basic stuff, which is how to configure iBGP or eBGP, but rather we'll be discussing more about those amazing features which can make the configurations even better. Other than routing protocols, we'll be talking about policy-based routings under the layer 3 section. We'll be talking about things like how VRF works. We'll be talking about then how the troubleshootings can be done related to specifically administrative distance or related to some policies which we might observe in the production environments. So what idea I want you to take here is that the protocols which we will be talking about will not be just the basics, rather the advanced features related to those protocols will be discussed in the NRC part. After we are done with layer 3 technologies, we'll jump on to the second part, which is VPN technologies. Now we all very well know how important VPN is, right? So VPN will be discovering in detail how it works, what are the various types of configurations, what is various types of tunneling concepts like GRE, like IPsec. Then we can say how MPLS works. We'll be getting the basics of that also. How DM VPN can be configured, how that works. All such things we'll be talking about under the VPN technologies sections. Then after that, we'll be jumping on to infrastructure security. Now the security section also contains a lot of topics related to how we can ensure that the network is not just connected, but rather it is also safe or it is also secure. So what all security protocols are there. You might have heard of AAA. So we'll be talking about that. We'll be talking about ACLs, extended ACLs, standard ACL, time-based ACL, all such things. Then IPv6 traffic filters are there. We'll be talking about those things. Then URPF is one of the topic which we'll be talking about in the NRC section. How to troubleshoot various things which you have already learned in your ENCOR section, which basically includes things like telnet, SSH, then control plane policies, how to troubleshoot all these things, then SNMP, EIGRP, OSPF, how to make sure that these are secure, they are not sharing information unsecurely or which is not safe. So we'll be talking about all such things here under the security section. Then after that, once we are good with that, we'll be talking about the last section of the NRC part, which is your services, infrastructure services. So under infrastructure services, we talk again about things like SNMP, SNMP versions, then how syslog works, how debugs work, how conditional debugs can be configured. So these things will help you in understanding how actually things work in the production environments and how you can actually come out of some troubles which you might observe when you work with real life networks. These will give you a good idea of how you are supposed to troubleshoot various kinds of uh, issues which you might observe in the production environments. Things related to IPv4 as well as IPv6, DHCP, how to configure that, how to use IPSLA, how to use SNMP, how to ensure that syslogs are being stored into a particular server, how DNS center works. So we'll talk about all such things under the NRC section. This is going to be the content, and we will be talking about all the topics which we have seen in the official syllabus of NRC provided by Cisco. So we'll be talking about all those things. That's going to be the same. The same is going to be the flow of the training. We'll be first discussing about layer 3 things, route redistributions, protocols, policy-based routings, all such things. Then we'll be jumping on to VPNs, then securities, then services. So this is one thing about NRC. And as I mentioned earlier, when I talk about NRC, when I talk about participants who are going to be a part of this NRC training, I expect them to have the knowledge of ENCOR level. Because as I mentioned, this is where you will explore about the details, not the basics. So this is one thing which I expect from the participants of that particular batch, right? Other than that, you can rest assured that whatever we will discuss, we'll discuss from very possible basics. Like I'll try to make things easier, which can help you in grasping protocols. And the topic which we have got for today is VRF. So let's talk about that. Let's try to understand how VRF works. In between, you get any questions, you can post your questions in the chat box, and I'll be answering them by the end of the session. All right, so now we are going to talk about very amazing technology, VRF. VRF, first of all, stands for Virtual Routing and Forwarding. Now let's try to understand what exactly this helps us with. When I talk about VRF, VRF is used for creating multiple routing tables. Just understand it like this. So we have seen that we put the configurations of routing protocols and we run the command show IP route, and we get to see the networks into the routing protocols. I mean, we get to see the networks into the routing table, right? But is it possible to have more than one routing table in the router? What do you think? Let me know in the chat box. Do you think it is possible to have more than one routing table? You can make guesses. Just let me know with yes or no in the chat box. No, right? What we have till now observed is just a single routing table. That's it. And what VRF is going to help us with is creating more than one routing table. So you observe the global instance of your routing table. What do we get to see? We get to see the global instance, which is the default routing table. But just like that global instance, you can create multiple instances, which is basically what VRF is all about. So creating those instances to separate routing tables is what we observe in VRF. So VRF is a process in which what you do is, let's assume that this is your router. So what you will do is you will create multiple virtual routers inside your routers. So it is a process of creating multiple virtual routers inside your one physical device. That means the single router which you have, now you will use it in multiple networks in multiple instances. This is going to have a separate routing table. This router will have a separate one. This router will have a separate one. But actually, when I talk about all of them together, this is just a single physical device. This is VRF, what VRF is going to help us with. So when I talk about VRF, the VRF is something which we can configure or which can be used by following some basic steps. We'll be talking about them one by one, but let's first of all try to understand how the topology or how a example of VRF would look like. So let's say I have a router number one. Now this router number one is connected with router number two, and then further router two is connected with router three. Then we can say this router one is connected to two LAN networks. We have a PC1 here connected in the LAN 1, then we have a PC2 connected in the LAN 2. Similarly, on the other side also, R3 is also further connected with two LAN networks. One is connected to PC1 and one is connected to PC2. Now, what I want is, I don't want the PC1 of my LAN 1, which is basically this area. So I don't want the PC1 of my LAN 1 to interfere in any sort of communication which my PC2 is doing. So I want to keep these two things as separate routing tables. I want to keep the first network into a separate section and the second one into a separate section. But the question is why? What is the use of creating all these sections? That's the very first question which I get in my mind, right? Why do I have to separate these things? So what I'll do is I'll create this using VRF. That's one thing which is clear to me. But what it is going to help us with, we can say it will allow us with the better management. It will allow us with the better security. We will be ensuring that there is no overlapping of IP. Now what I'll do is, even I can use the same IP addresses. I'll show you this with the example that will make more sense at that time. But yeah, we can use the same IP on this interface and this interface. Do you think that is possible with the global instance? Can we have two interfaces with the same IP? No, right? That's not possible. That's going to give us the errors related to overlapping IP. But when I have separated the routing tables itself, then I can do that, because my first IP is a part of different routing table. My second IP is a part of different routing table. So these are now two different instances. These are now two different scenarios in which there is not going to be any error related to overlapping, even if we use the same IP. So all such things are there when we talk about the advantages of VRF. So because of achieving all these things, I can configure VRF. The question is how it is configured. So the VRF configurations is very simple. The very first step which you can do to begin with the VRF configuration is creating instances. So what is step number one? Creating instances. The first thing I need to tell my router is that how many instances I want to create, right? Step two, interface memberships. Telling the router that the first interface is a part of VRF1 and the second interface is a part of VRF2. That's going to be my second step. What after that? What after that? Simply, if I want to build a kind of communication, then step 3 would be simply configuring routing. That's it. Following these steps only, we'll try to do a lab here and we'll try to see how things work when it comes to VRF configuration. So Ronald, there can be VLANs, but this is now a layer 3 discussion, or we can say this is a technology which works with IP, which is a layer 3 protocol. So it's not going to make any impact. But when I talk about this section, which is just connected to switches, then definitely you can have VLANs there. Now let's see how this configuration works. So I have already kept one lab ready with me because of the limited time. So let me share my other screen now. Perfect. Great. So as of now, what we see on the screen is we have 6 routers. R1, R2 are connected together. Then R3, R4 basically are 2 routers. R3 is a part of customer A instance. R4 is a part of customer B instance. Let's forget about this section of my topology, the right side section, for the time being. I'll not discuss about this part right now. Let's first understand the VRF concept with just these 3 routers. Then we will see how it can be configured with the rest of the topology also. So as of now, the very first step I'll do is, I can see the first step I have written here is build the network and configure basic device settings. So let's do that. Let's go to the router 1 CLI and let's begin the configurations. All right, here is my router, enable config T, host name R1. I'll go to my interface gig 0/0 and I'll put the IP 12.10.1.1. 255.255.255.252. Now that's an IP which we have given on gig 00, which is this, the interface connecting to router 2. So that's not a part of any VRF. But when I talk about the remaining 2 interfaces, I have got gig 01 and gig 02. Gig 01 is going to be a part of customer B's instance, and then gig 02 is going to be a part of customer A's instance, right? So let's first of all create these instances. The first step, the command is very easy, IP VRF A, that will create an instance called A, then IP VRF B, exit. This 2 commands have created 2 instances, VRF A and VRF B. After that, the next section was making interface memberships. So let's do that now. Let's make gig 0/2 a part of VRF A and then gig 0/1 a part of VRF B. So I'll go to interface gig 0/2. There I'll use the command IP VRF forwarding A. After that, I'll assign the IP address to it, 11.11.11.1/24 subnet, no shutdown, exit. Now what I'll do is I'll go to interface. Okay, the interface is up now. So let's go to the next interface, gig 0/1. The first command, IP VRF forwarding. This time I'll mention the instance name as B. So IP VRF forwarding B, IP address 11.11.11.1. But wait a second, this is the same IP which we have used on gig 0/2. And as per our understanding, this is not possible. But see this, guys, when I run the command, it doesn't give me any overlapping error because, as I mentioned, they are now part of 2 different routing protocols. I can say no shutdown to make the interface up and then simply exit. Now this has created 2 VRF instances and has also made interface number gig 0/1 a part of VRF B and gig 0/2 a part of VRF A. So how can we check these details? Let's go back to the privilege mode and say show IP VRF, enter. So it prints out the list of VRF instances. We have 2 instances, A and B. Under A, we have the interface gig 0/2. Under B, we have gig 0/1. Then if I say show IP interface brief, then you can see gig01, gig02, both are there with the same IP. So that is possible through VRF. Let's do the same thing on router 2 quickly. So I'll go to router 2. Enable config T, hostname R2, interface gig 0/1. Okay, before that, I need to create VRF instances. So IP VRF A, IP VRF B, exit, interface gig 0/1, IP VRF forwarding A, IP address 22.22.22.1/24 subnet, no shutdown, exit, then interface gig 0/2. This will be a part of VRFB, right? So IP VRF forwarding B, IP address, the same IP 22.22.22.1/24 subnet, no shutdown, exit. Again, I can verify things by running show command, show IP interface brief. We can see the same IPs there. Now let's do the configuration on the remaining routers also. So let's put the IP addresses on router 3, router 4, router 5, router 6 also. So let's begin it from router 3. I'll quickly make the IP configurations there. Now on router 3, we don't have to create any VRF, right? Because router 3 is simply a part of the customer side. So we don't have to put configuration on that router. We will simply put the IP there. So enable config T interface gig 0/0. After that, IP address 11.11.11.2/24 subnet, no shutdown, exit. And I'll go to router 4, enable config T hostname R4, interface gig 0/0, IP address 11.11.11.2/24 subnet, no shutdown, exit. Then I'll go to router 5. That's my router 5. Enable config T host name R5, interface gig 0/0, IP address 22.22.22.2/24 subnet, no shutdown, exit. Then last thing is configuring router 6. So let's go to that now. Enable config T hostname R6, interface gig 0/0, IP address 22.22.22.2/24 subnet, and then no shutdown, exit. So we have successfully given the configurations of IP address on all the devices, as well as we have created both the VRF instances on router number 1 and router number 2. Now the task is to build a connectivity between customer A router 3 and customer A's router 5, basically these two devices. Similarly, these two devices. But for doing that, what we need is we need routing protocol. So this is the time where we will understand how to integrate OSPF with VRF. So let's see how that configuration will work. But before we jump onto that, I have a quick question. What do you think this gig 0 to gig 0 connectivity between R1 and R2? What do you think? Which VRF will they participate in? Will they participate in VRF A or VRF B? Any idea? Any guesses? Let me know in the chat box. VRF A or VRF B? A. Okay. Okay, I can see the response as A. So if I put them in A, that will build the connectivity with R3 to R5. That's pretty good. But when I want R4 to R6 connectivity, what will I do at that time? Because now the connecting interface is a part of VRF A, right? So what we do in such a scenario is when we want a single physical interface into multiple VRF. Try to understand this point here. When you want your single interface to be a part of multiple VRF instances, what we do is we create sub interfaces. I'll create more than one sub interface on my router, will make one sub interface a part of VRF A and one sub interface a part of VRF B. That's the solution there. So even when you have a single physical link, then also this is achievable by creating sub interfaces. Now what I'll do is I'll create sub interface on my router 1 and router 2, and then first sub interface will be a part of VRF A, then similarly second will be a part of VRF B. So I'll just put the configuration first of all for customer A to customer A connectivity. So let me first do that. I'll remove the IP from gig 00, config T, default interface gig 00. Do show IP interface brief. Now we no longer have any IP on that. So let's go to gig 00. Let's make it up first of all. No shutdown, exit. Once the interface comes up, I'll begin the configuration of sub interfaces. So interface gig 0/0.1 encapsulation .1q will make it a part of, let's say, VLAN 2. Then the IP I'll assign to it is going to be 12.10.1.1 with the /30 subnet. But before that, I need to make it a part of VRF-A. Why I'm saying that before that I need to make it a part of VRF-A? Let's see what happens if we make it a part of VRF-A after we have configured the IP on it. So if you put it into VRF-A after configuring the IP will get disappeared, or you can say it will be removed from your interface. You can see here that gig 00/.1 disabled and addresses are removed due to disabling VRF-A. So since now it is a part of VRF-A, the previous IP will be removed from it. So make sure you are making the interface a part of your VRF first, then you are putting the IP on it. So let's put the IP again on it, 12.10.1.1/30, no shutdown, exit. Similarly, I'll go to router 2 and we'll put the sub interface configurations there. This is my router 2, config T interface gig 0/0, no shutdown, exit. Once the interface comes up, I will begin the configuration of sub interface. So my interface is up now. Let's create the sub interface. So interface gig 0/0.1 IP, or even before that, encapsulation .1q to IP VRF A IP address. I think we'll have to do it again. Gig 0/0.1, then IP VRF forwarding A, and then IP address 12.10.1.2/30 subnet. And then I can take the exit, no shutdown, exit. Let's test the connectivity. So I'll send a ping message to 12.10.11. Connectivity is not there. Let's try to understand the reason behind this. So when I say ping 12.10.1.1, my router will start looking into the routing table. When I run the command show IP route, I don't have any route in my routing table. Why? Because in the global instance, we haven't done any configurations, right? We have created the separate instance, which is VRF-A. So if I run the command show IP route VRF-A, then it shows me the route because these are now part of a separate routing table, remember? Similarly, when I try to say ping 12.10.1.1, I have to specify the VRF as A. So that's going to be ping VRF A 12.10.11. And when I do it like this, I can observe the replies because now the router will check the routing table as per the VRF-A, not the global instance, not the one which is there by default. So this is how you can make sure that you are working with it correctly. Now the next thing, or we can say the last thing, is putting some routing protocol so that router 3 can communicate with router 5, both the customer A routers. Now this can be achieved by EIGRP also, but I would like to mention here that requires the understanding of address families, which we discuss in the NRC section. So I'm skipping that thing here. Rather than that, I'll put the configurations of OSPF, which I am pretty sure that you all must be aware of. So we'll put OSPF configuration. Let's begin it from router 3. Let's go to router 3 and begin the OSPF configurations there. So router OSPF, let's say the process ID 10. Then I'll put the network 11.11.11.0 with the wildcard bits 0000255 into the area 1. Exit. Similarly, we'll do the same configurations on router 5 for the network 22.22.22.0. Router OSPF 10, network 22.22.22.0000255, area 1. Exit. Now we have to put it on router 1 and router 2. So let's go to router 1. On router 1, if I say router OSPF 10, that will create the OSPF process for my routing table, which is there by default. But if I specify VRF-A, then it will be done for VRF-A specifically. Under VRF-A's routing table, we can say we want to add the network 12.10.1.0.0003 into the area 1, and then another network which is connected to me 11.11.11.0.0000255 into the area 1. Exit. After some time, R1 will become neighbor with R3. Let's put the configurations on router 2 also. This is my router 2. We can see the neighborship is up with my router 3 here. Now I'll go to my router 2, config T, router OSPF 10 VRF-A. I'll add the network 22.22.22.0.0000255 area 1, and then network 12.10.1.0.003 into the area 1. We can already see the logs specifying that the neighborship is up. Perfect. Now the neighborships are up. If I go to my router 3 and I check my routing table there, show IP route. So we can see the routes for reaching 22.22.22.0 network. If I say ping 22.22.22.2, which is the router 5 of my topology, if I try to ping that, so I have the connectivity, I have the reachability there. But here I also have a question for you guys. How can I say that this is the router 5, not router 6? How is that possible? It can be router 6 also, right? We have given the same IP on router 6. Let me know in the chat box, what is the reason behind that we are saying that this connectivity is with router 5? How can we say that? Any idea, any guesses? Yes, please let me know in the chat box, Ronald. My question is, guys, that when I say I am pinging the IP 22.22.22.2, how can I say that this is the reply from router 5, not from router 6? Because router 6 is there with the same IP address, right? So what is the reason behind we are saying that router 3 is communicating with router 5 right now, not with router 6? What is the logic or what is the reason behind that? What do you think? No worries, let's try to understand it here. When I say a packet comes from router 3, one thing is clear to my router 1, that this packet is coming to me from what VRF? VRF-A, right? Because my gig 0/2, the receiving interface, is a part of VRF-A. Now when I get that packet, I get to see that the destination is 22.22.22.2. But since the packet is a part of VRF-A, I will not check the VRF-B routing table. I'll check just the VRF-A routing table. When I look into that routing table, let me see if I have any information about 22.22.22.0 network or not. So let's go to router 1. Let's check the VRF-A routing table. Let's see, do we have any information there? Show IP route VRF-A. When I check that, I get to see a route 22.22.22.0 via 12.10.1.2. So it will give it to router 2. Now again, the same logic. We are getting this from VRF A. So my router 2 again will look into the routing table of VRF A only. Show IP route VRF A. Do we have any route to that? Yes, we have a directly connected route. So we'll give it to that particular interface gig 0/1, and that will be just received by my router 5, even when router 6 is having the same IP. So this is the logic. I hope this is clear now. If there is any questions, then you can put that in the chat box. Now, similarly, just like I have created the connectivity between my router 3 and router 5, just like that, similarly, by using OSPF configurations, I can also create a connectivity between router 4 and router 6 also. In the same way, like I have configured it for router 3 to router 5 configurations. So that was a quick introduction to how VRF works. Now you guys can put your questions or doubts related to this in the chat box here in the Teams app, and I'll be answering your questions here. And if you don't have any questions, then you can also mention that in the chat box. Okay, so Rupesh has this question that how can we ping from VRF A to VRF B? So Rupesh, the logic behind creating different instances is just to make sure that the VRF A cannot interfere in the VRF-B communications. So why would I put the same networks onto a router? The reason behind that is that I want to keep things segregated. I want to ensure that that is a different section where my router 3 and router 5 can communicate, and router 4 to router 6 connectivity is a different section. Then the next question we have is, in which instance is this applied in the real world scenario? So it is highly used in enterprise. It is highly used in ISP environments where you have multiple networks coming in from the various customers. Now the management of that can be done just simply by creating multiple routers inside our physical device, which is achieved through VRF. Then we have a question that what number of routing tables do we have here? So we have created 2, and by default there is 1. So total we have 3 here. The one is for VRF-A. So if I go in router 1, I check show IP route and I mention VRF-A. That's my first VRF routing table. Then if I check show IP route VRF-B, then this is the second one. We don't see the route for 22.22.22.0 network because that is going to installed after the OSPF configuration, which we are not going to do right now in this session. After that, if I check show IP route simply without mentioning any VRF, then we get to see the global instance where we don't have any routes because the interfaces are participating into the VRF.